Hi everyone, welcome to this week's lesson for junior cycle ordinary level. Today we're going to go through an introduction to coordinate geometry. So we're going to be going through different theory components and using the x and y coordinate diagram, and then that will be followed by some exam questions and their solutions. Okay, so in this lesson we will introduce some of the basic ideas of coordinate geometry. Our geometry takes place in a plane, which we will think of as a large sheet of paper, or in fact an infinitely large sheet of paper. On the plane we can draw geometric shapes and objects such as lines and points. We will also consider other shapes like triangles, circles and squares. Geometry deals with questions about objects like these. A type of question we might consider is whether a point lies on a certain line. Where do lines intersect, or what is the area of a triangle? The basic idea of coordinate geometry is that many geometric questions can be answered using the tools we know from algebra. So if we want to use algebra to solve geometry problems, we first need to convert concepts of points and lines into numbers and equations. The basic device to convert geometry into algebra is to introduce coordinates. So on the plane we can draw two perpendicular lines. So perpendicular is when a line looks like this, so it's like a T upside down, or it could be like a T shape. So we call these the coordinate axes, which we normally label the x-axis and the y-axis. These coordinate axes are the reference points for our coordinate system. If we take some point on the plane, which is shown in red, we can associate it to that point coordinates by projecting the point to the axis as seen in the diagram below. So I'm just going to scroll down here. We can think of these two lines as two real number lines, and the point where the two axes cross has an x and y coordinate of 0, 0. Okay, so as you can see, this is the x-axis and this is the y-axis. So if we were to write down this point here, so you can see it there in the diagram, we first of all go down, so x comes first in the alphabet, so we go down to see what number that corresponds to on the x-axis, and then you go across and see what number it corresponds to on the y-axis, and then you always put it in the format where it goes, the x number goes first and the y number goes second. So think of the alphabet, which one comes first, and that's how you label your points. So at the point where our projection meets the x-axis is shown by the broken blue line. This will have some number associated with it, which we can call a. Similarly, the point where the projection line to the y-axis can be called b. We can then associate the numbers a and b to our point, and therefore a and b are the coordinates of the red point in the diagram, which is here. So we'll go to look at the first example here. So it asks us to plot the points 3, 1. And they're saying that p is minus 2, 2, and also p, which is 2, 3. So those 3 points they want us to plot. So we'll look at the first one there, so 3, 1. So that means that x has a value of 3 and y has a value of 1. So if we look at the coordinate diagram, we're going to go to where the x-axis is first, because that's always the first number. So we go to where 3 is, and we go, so that's where 3 is on the x-axis. And if we look at the second number, it's 1 on the y-axis. Now 1 on the y-axis is here. So you're going to draw a line to see where those 2 points meet, and then you have the point 3, 1. The second point, minus 2, 2. So if you go to minus 2 on the x-axis, so minus 2 on the x-axis is going to be here. And you go to where 2 is on the y-axis. So you go up to where 2 is on the y-axis, which is here. And it has the broken line done there for you. So you see where those points meet, and that's the point minus 2, 2. And then finally the point 2, 3. So 2 on the x-axis and minus 3 on the y-axis. So we go to where 2 is on the x-axis, which is here. And we go to where minus 3 is on the y-axis, which is here. So you need to draw a broken line to join where these points would meet. And there you have the point 2 and minus 3. So with these points, it's very, very important to make sure that you put the x coordinate first and the y coordinate second. So there is a special point whose coordinates are 0, 0. Okay, so you can see on this diagram here, this is the point 0, 0, and this is called the origin. That's a really important term, and that's going to come up again and again, so it's important that you know what that is. it is at this point at which the two coordinate axes meet. So what that means is that the x-axis meets the y-axis at that point, because this is x, this is y, and they meet at that point there. If we also draw our coordinate axes again, we can see that they divide into a plane in 4 different regions, which are shown in the diagram below. We can associate to these regions a pattern in the coordinates. In the blue region, x and y are positive. So if you can see there, x values, they go from 1, 2, 3, and they go on up, and then the y goes from 0, 1, 2, 3, and it continues on up. So they're all positive. So then if we look at the red region, the x coordinate is negative, because you can see here you have -1, -2, -3, -4. So you have x, which is negative, and you have y, which is going to be positive because it's going up. Then the next region there is the yellow region. So the x coordinate in this case is positive because it's going this way, and the y coordinate is negative because it's going this way. So you've got x, which is positive, and you have y, which is negative. And then finally in the green region, x and y are both negative because x is going this way and y is going this way. So your x is negative and your y is also negative. So just important to be aware of what's going on in each of those regions. So when we see a point, just by looking at the sign of the x and y coordinates, we can immediately identify it to belonging to one of these 4 regions. If the x coordinate is 0, then the point is somewhere on the y-axis, and similarly, if the y coordinate is 0, then the point is somewhere on the x-axis. So we'll get to that a bit later. So the next thing we're looking at is the slope of the line. Now, first of all, when we think of slope, I want you to associate the word steepness with that. So slope refers to how steep a line is. So in the previous lesson, you might have seen this before, y is equal to mx corresponds to the line through the origin where you have the point 0, 0. In this lesson, we're going to look at the meaning of the constant m. So m means slope. That's really important that you know that that letter signifies slope. We can look at a number of different examples of lines with different values of m in the diagram below. Now, the higher or the greater the slope, the steeper the line. Now, we'll just show that. So if we look at m equals 0, so it's not really a slope there at all, it's just going on a straight line. This is where you have a slope of 1. So there's a certain level of steepness there. Where you have m is equal to 5, that's a lot steeper again. And then you have m is equal to -2. You can see that the slope is decreasing here in this case. So when m is increased, we can see that the line becomes steeper. So that's what I just explained there. So when m is increased, we can see that the line becomes steeper. Then when we have m is equal to 0, we can see that the line is the same as the x-axis. So it'll give us the equation y is equal to 0. Then if we decrease m such that m becomes negative, we see that the line is going down. So from these examples, we can see that m measures the steepness of the slope of the line. So m is the slope of the line, y is equal to mx. So in that case, it's m is your slope. So remember that letter is associated with the slope. So what we mean by the slope of the line is that the change in the y coordinate divided by the corresponding change in the x coordinate. So that's just what m actually signifies. Another way of interpreting this is to say that the slope is a measure of how much the y coordinate changes for every unit that the x coordinate changes, and it's sometimes called rise over run. So this leads us into our next equation. So slope of a line joining 2 points. When you're given 2 points, this is how you get the slope of the line containing these 2 points. So suppose we are given 2 points, we can draw a line through these points, and we might ask, what is the slope of this line? We remember that the slope is, so m, which is your slope, again, remember that letter means slope. So m is equal to the change in y over the change in x. So an example here, what is the slope of the line containing the points? You have -2, 3, so that's going to be x1, y1. That's the first point. and 3, 1, we're going to call this x2, y2. So always label your points. I'm going to put that in here because it will really help and there'll be less scope for mistakes. So always label the points. So first we calculate how much the y coordinate changes between the 2 points. 3 minus 1 is equal to 2. So I'm just going to write up, now you'll see the formula here. So it's y2 minus y1 over x2 minus x1. So that's the difference in both of them. So y2 in this case is 1. So it's going to be 1 take away y1, which is 3. So it's 1 minus 3 over x2 is 3. So it's going to be 3 take away x1. Now be careful here, that's minus 2. So when you have two minuses, it's going to become a plus. 1 minus 3 is minus 2. And 3 minus minus 2 becomes 3 plus 2. Then you get minus 2 over 5. And that's your slope, which is here. So in general, the slope of the line containing x1 and x1, y1 and x2, y2, this formula here, and this is given in your log tables. So you don't have to learn that off, but you do have to know how to apply it. So it's the difference in the y coordinates over the difference of the x coordinates. So we have another example here. What is the slope of the line joining the points 1, 3 and 7, 10? So we'll label that x1, y1 and x2, y2. So m is equal to y2 minus y1 over x2 minus x1. So m is equal to, so y2 is going to be 10, take away y1, which is 3, over x2, which is 7, take away x1, which is 1. So 7 minus 3 is 10, 10 minus 3 is 7, and then 7 minus 1 is 6, so 7 over 6, which is the slope. This brings us into the next section, which is the length or distance. So in this particular part, we're going to discuss another basic concept in geometry, that's the length or distance. So suppose we're given 2 points through which we can draw a line. So say, for example, you have this point and you have this point, you can draw a line in between the 2 points. So if you wanted to get the distance between those 2 points, we apply this method here. So we might only be interested in the line segment between 2 points and the length of the segment. Or equivalently, what is the distance between the 2 points? So the key tool we use here is Pythagoras Theorem, which deals with right-angled triangles. I'm just going to underline that because you can only apply Pythagoras Theorem with right-angled triangles. So with the sides of length A, B and the hypotenuse C is shown in the diagram below. So we know that the rule is the hypotenuse squared is equal to the sum of the adjacent squared plus the opposite squared. So in this case, the hypotenuse squared is C. So C squared is equal to A squared plus B squared, which is where they're getting this from. Okay. So we can use this to identify a right angle triangle on the graph of the line segment as seen in the diagram below. If we draw a vertical line down from the point -2, 3, and a horizontal line from across from 2, -1, we can see that the lines make a right angle triangle. Okay, so I'm just going to explain what's going on here. This, the line in blue is the line that you're given. What they have done is they have joined up. They've drawn a line that going down this way and a line across this way, and what has resulted is a right angle triangle. We can see that the lines make a right angle triangle with the line segment as the hypotenuse. So what you have as your line segment now becomes your hypotenuse. The coordinates of the point of the right angle of the triangle has the same x coordinates as -2, 3, and the same y coordinate as 2, -1. So it has coordinates 2, -1. If we work out the length of the vertical and horizontal lines, we can use Pythagoras' theorem to find the length of the line segment. The length of the vertical line is going to be the difference in the y coordinates, so that the length is 3 minus -1 is equal to 4. Similarly, the length of the horizontal line is the difference in the x coordinates, which is 2 minus -4. Okay, so I'm just going to explain that a little bit clearer. So what's happening there is they're saying if you can calculate the distance from here to here, you will get that value. If you calculate the distance from here to here, you will get a value, and then you'll be able to calculate the distance from here to here. So you need to get a definite value. That's for a right angle triangle. Now this brings us on to the next, it kind of leads us on to the next equation. Then this is given to you in your log tables. So the general equation for the distance between 2 points is this. So your distance, it's this formula here. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, best way to explain this is to use an example. So what is the distance between 2 and 1 and 5 and minus 1? So we're going to do the first thing here and label it. So x1, y1, x2, y2. Now we're going to write out our formula. So the distance formula is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So we're just going to fill in what we have. So x2 in this case is 5, so I've just labelled it, minus x1 is 2 squared, plus y2 in this case is minus 1, so minus 1, take away 1. So 5 minus 2 is 3, 3 squared is 9, minus 1 is minus 2, and minus 2 squared is 4. And always when you square a negative number, it becomes positive. Then you get the square root of 13. Now, if that doesn't give you an even number, you just leave it in the root form, in third form. So that's your answer there, which corresponds to this answer here. So we are on to midpoint now. So the midpoint of a line. Okay, so we're going to look at answering a question of how to find the midpoint of a line segment. So suppose we know the coordinates of the two endpoints of the segment. The midpoint would be the point that is equidistant from both endpoints. So I'm going to just show you an example here. If I draw a line, and I'm going to call that point A, and I'm going to call this point B. So the midpoint is bang slam in the middle of the line, so it'll be somewhere around here. Now, the distance from A to that midpoint would be the same distance from the midpoint to B. So these should both be the same. And there's a way of finding out the midpoint as well. So if you look at that coordinate diagram on the screen there, they have the midpoint highlighted in red. So there's, again, a way of finding that out when you're given two sets of points. So we can see from the diagram above that you would expect the x-coordinate to be the midpoint of halfway between x2 and x1, so that would be roughly here. And then the same for the y-coordinate would be roughly here. Now if you join them up, you get this point. But there's an easier way of doing that, and that's using a formula. So if we take the average value of x1 and x2, we can get the x-coordinate of the midpoint, and again for the y-coordinate. So the midpoint of the line segment with endpoints is, so this formula here, this is given to you in your log tables, you have to know how to apply it. Okay, so the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. Now remember that the midpoint is a point, so you're going to be looking for an x value and a y value. So this brings us on to another example. Find the midpoint of the line segment PQ. So P is 1, 5, so that's going to be x1, y1. And Q is 1, 3, so x2, y2. So I'm going to do this out. So the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. So we're going to fill that in now. x1 is 1 plus x2 is 1. So that's x1 and x2 over 2. Comma, y1, which is 5, plus y2, which is 3, over 2. So 1 plus 1 is 2. 2 divided by 2 is 1. Then we have 5 plus 3, which is 8. 8 divided by 2 is 4. So the midpoint there is 1 and 4. So that's your midpoint. Now I see on this example, they've actually switched the point to 3, 1 instead of 1, 3. So I'm going to redraw it. I'll just show you what it should look like. So you have your coordinate diagram. So you have x and you have y. This isn't drawn to scale. But you have, so your first point is 1, 5. So the point 1, 5. So we'll say 1, 2, 3. We'll say 1, 2, 3, 4, 5. And as I said, this isn't done to scale. So the point 1, 5 would be roughly here. Then your other point was 1, 3. So the point 1, 3 would be roughly there. Or sorry, yeah, there. 1, 3, and then our midpoint was the point 1, 4, so that would make sense. So I'm going to draw the midpoint in here, which is, yeah, there's your midpoint of the line. So that's what it should look like. Okay, so we're on to the papers now. So the first question I have there is 2011, paper 2, question 12. Okay, so it asks us first of all to plot the points -2, -2. So that's your x coordinate, that's your y coordinate. So go to where -2 is on the x-axis. So I'm going to mark it in here. So I'm going to mark it in with an X, and we go to where -2 is on the y-axis as well. I'm going to mark this in with an X. So what you do then is you join up your points. So, sorry, go to where -2 is on the y-axis, which is here, and this is where they should join up. So you come across and down, see where they meet, and it joins at this point here. So that's going to be your first point. So that is the point A. The next point is 6 -2. So go to where x is 6, which is here, and you go to where y is -2, which is down here again. So you're going to see where they meet. So you go to where y is -2, come across and see where it meets x is 6, which is here. So that's your next point. This is the point B. Your next point then is 7, 3. So you go to where x is 7, which is here, and you go to where y is 3, which is here, and you're going to come across and down to see where they meet. So come across and down. So your point is going to be there. So that's the point C. And then finally you have the point D. Oh no, we don't have D. We just have A, B, and C. Okay, so I'm just going to highlight these again. So this is the point A, the point B, and the point C. Now, they're asking us to construct the point D such that A, B, C, D is a parallelogram and write down its coordinates. Now the way you do this, if it's a parallelogram, that means the opposite sides must be equal. So if we look at the point A and we count how many units on the x-axis it takes to get to B. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to do the same thing now. We're going to go up to C and we're going to count back 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's our point. So our point D is going to be the point -1 and 3, which is here. So that's your point D. And it says to construct it such that it's a parallelogram. So you join up your points. Now you'd obviously use a ruler for this. And there's your parallelogram forming. Okay, so the coordinates of D is -1 and 3. Now in question 9 on page 9, you identify some properties of a parallelogram. Write down one of these. Now we didn't do question 9, but we do know some properties of a parallelogram. So the most common one is that opposite sides are parallel or equal. So opposite sides are parallel or equal. So that would be perfect for that one. For D, using the coordinate geometry formulae, verify that A, B, C, D has the property that you wrote down in C above. Okay, so I'm going to go for opposite sides are equal. I'm just going to write this down again. So opposite sides are equal. So we need to prove that. So if we go back up here for a second. So I'm going to use my highlighter again. So opposite sides are equal. That means that the side DC equals the side AB. So the distance from C to D or C to D equals the distance from A to B. Now we actually proved that when we were figuring out the point D, because we figured out, if you see in orange there, that the distance from C to D was 8 units, and also the distance from A to B was 8 units. So we can write that down. So the distance from A to B equals the distance from C to D, and that was 8 units. We figured that out already. Now we also need to figure out the other two sides. So the other two sides that should be equal are AD. So AD, which is this side here, should be equal to CB, which is this side here. Now we're going to need to use the formula to solve that question. So we'll write out what each point is first. So A is the point 2, minus 2, minus 2. And the point D from the diagram we figured out is minus 1 and 3. Minus 1 and 3. So we need to get the distance from A to D. Okay, so that's going to be x1, y1, x2, y2. So the formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. So put that into the formula. Y2 is 3 minus y1 is minus 2 in this case. So squared plus x2 in this case is minus 1. Take away x1, which is minus 2, and squared. Okay. This becomes plus. The 2 minuses become a plus. So 3 plus 2 is 5. 5 squared is 25. Minus 1 plus 2, this becomes. So minus 1 plus 2 is 1. So 1 squared is 1. So that becomes the root of 26. Now, so the distance from A to D is 26. So we also need to now figure out the distance from B to C. So the point B is 6 minus 2. And the point C from the diagram is 7, 3. So we're going to fill these in. So x1, y1, x2, y2. So we're putting them into the formula again. The square root of y2 minus y1 squared plus x2 minus x1 squared. So y2 in this case is 3 minus y1, which is minus 2, squared plus x2 in this case is 7 minus x1 is 6 squared. So 3 minus minus 2 becomes plus, so 3 plus 2 is 5, 5 squared is 25, and then 7 minus 6 is 1, 1 squared is 1. So that's also the root of 26. So the distance from B to C is the same as the distance from A to D. So that's, you've just proved now that the property that we wrote down in the previous question is correct. Just check how much, we could do one more question in the time that we have. Let me see now. I was trying to find a suitable one. Okay, we'll do this one. We're just going to write down the coordinates of each item. So the coordinates meaning the x and y point. So I'm going to do them onto the diagram. So if we look at the point B there first. So if we go, so it's at the point 2 on the x-axis. So we go all the way up and across. So that's going to be the point 2, 7. So 2 on the x-axis and 7 on the y-axis. This point S here, so go to where it is on the x-axis, which is 2, and go across on the y-axis, and it's 7. Sorry, it's 2, 1. I was thinking of something wrong there. It's 2, 1. So 1 on the y-axis and 2 on the x-axis, the point 2, 1. Then we look at the point R, so come down to see where it is on the x-axis, so it's 6, and go across to see what it is on the y-axis, and it's 4. And then finally the point P, come down, it's 7 on the x-axis, and come across again, and it's the same, it's going to be 1 on the y-axis. And then finally the point T, come down, and it's the point 9, and then go across for the y-axis, and it's 5, so the point 9, 5. Okay, so that's all we have time for today, unfortunately, but I am going to attach some extra links to some video tutorials and also some extra exam questions and solutions. So I'd recommend that you follow that link or those links, and I will speak to you next week.